Okay, so as we finish up Module 8, we're going to talk about triangle proportionality and then parts of proportional triangles. And so looking here, triangle proportionality theorem. If a line is parallel to one side of the triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So they're saying that if I have a line that is parallel to one side of the triangle, then it divides the sides into proportional lengths. This is proportional to this, this is proportional to this. And then here it says if and the converse to that is if my sides are divided into proportional lengths, then the opposite sides there are going to be parallel. So that's what we're talking about here. So in this, they're telling me that since PQ is parallel to CD, then the proportion of PC and PB is equal to the proportion of QD and BQ. So BP and QC, so BP over QC is proportional to BQ over QD, and that's what they've set up here. That's how they've set up the equation. And so looking at this, let's see if they told me that the lines are parallel. QD is 14.5, BP is 9, PC is 15, and then we are trying to find the elusive BQ. And that's what they've done. They said they've set the equation up as 9 over 15 is equal to some value over 14.5. Then they did their cross multiplication, bam and bam, and came up with BQ is actually equal to 8.7. Okay, so again, using these consistencies. If for some reason, thinking about setting it up, sometimes we're like, did I set it up right? I said be consistent as we set up our proportions. So we're consistent we're consistent in this one as they set it up as 9 over 15. So they set this side of the triangle up against this side of the triangle. You could have also set it up as the top part of the triangle. For example, 9 over x would be using the top part of the triangle is equal to the bottom part of the triangle is equal to 15 over 14.5. When you cross multiply, you get 15x is equal to 9 times 14.5. And if you'll notice, this is the same statement as this. So you're going to get the same answer, and that's just about being consistent of how you set up your proportions. Okay, so looking at this check, they've given us some information, and what I've done is I've actually drawn the bigger triangle here because I didn't want to have them sitting on top of each other, but you can. Let's see here, GB is 14.4, BF is 4.8, GH, the entire length is 21, and they want me to find GC. So there's different ways to set this up, but what can I do here? Let's see, proportions. This is something we probably haven't talked about. But how about I'm looking for this half a length over here, this portion, which would be x over the proportion of it would be 14.4, right? So I'm trying to say this over this. So if I do the small piece over the small piece, then I need to do this piece over this. Darn it. But if I don't have that, if I don't have this piece, well, why don't I do the whole length over the whole length? So that will probably get me the same information I need. So 21, the entire side over the other side, which would be 14 plus 4 is 18 plus 19.2, 19.2, and now you can cross multiply and come up with the answer. And that will allow you to find this value and this value. So let's see, solving for x, I get 19x equals 21 times 14.4. Okay, so I did some math here, and it looks like 19.2, I did really poor job there. And then 19.2x, and then when I multiplied 21 times 14.4, I came up with 302.4. Dividing that by 19.4 on both sides, x is going to be equal to 15.75. So x is 15.75, which is the same as GC, and then CH would be the entire length minus 15.75, which is going to be equal to, I want to say 5.25. So that is one way to do that formula. So just thinking about using that consistency. Consistency was the short piece over the short piece, and then the long piece over the long piece. So being consistent, there's a lot of different ways to set up all my proportions for similarity. Here, looking at this one, using triangle proportions to determine if lines are parallel. Again, if these pieces are proportional, then my lines are parallel. So let's see here, in this diagram it said that WXY, in triangle WXY, YL is 5, LX is 20, JX is 4 times as long as WJ, well, we'll just call that unknown value. WJ is X, so the other side would be 4X. And then are those two things parallel? Well, we would have to do a proportion. And here they have it set it up as WJ over JX is equal to 1/4, and then LY over LX is equal to 1/4. So those proportions are equal, so therefore then these two lines are parallel. So doing that down here, let's see, what do we have? PQR, and that tells me that PK is, oops, didn't need that, right? PK is 34, KQ is 20, PJ is 1.7 of JR, and we're just going to call JR X since they didn't give it to us. So that would be 1.7X. And want to know, are these two things proportional? Well, again, being consistent, if I take 34 over 20, that is equal to 1.7. If I take 1.7x over x, that is equal to 1.7. So since those two proportions are the same, then we do, yes, have parallel lines. Okay. All right, let's see here. Missing segments and parallel lines, or sorry, mid-segments. Mid-segment is a unique item here. So looking at this, the mid-segment of a triangle is a segment that connects the midpoints of the legs of a triangle. So midpoint means that these two things are equal, right in the middle. Midpoint means that these two things are equal, we're right in the middle. Midpoint means these two things are equal, we're right in the middle. So every triangle has 3 mid-segments. 1, because we connected those 2 midpoints, we connected these 2 midpoints, we connected these 2 midpoints. And then the mid-segments of the triangle, and they've identified them just like we just did. And in the special case of proportionality, what we find, let's see, we're going to go over some details here, is the proportions since this is equal to this, and this is equal to this is parallel to the far side. So your mid-segment would be parallel to the far side of the triangle. So that's what they're saying here. The mid-segment of triangle is parallel to one side of the triangle, and its length is 1/2 the length of the other side. So this JK is 1/2 of FG. Or FG is 2 times JK, depending on how you want to think about it. Now, because of what that just told me, if I come back up here to these mid-segments that are drawn, if RP is 1/2 of CB, that means it is equal to those 3 segments are congruent. Same thing here. AB is 2 times, right, this. So those are equal. And then AC, PQ would be 1/2 of AC, which is 2 hash marks. So what we end up discovering is that we have actually, we have actually 3 triangles here. 1, 2, 3, 4 triangles that are all congruent. So those mid-segments actually created 4 congruent triangles based on side, side, side. So there you go. Looking at that, that's one of those things that we're able to derive. Proportional parts of parallel lines, very similar to think of here the trapezoid, right? When we had we can sort of think this is a trapezoid. When we had the mid-segment of a trapezoid, it was, it was parallel, and then we knew that this would be congruent to this, and this would be congruent to that. Remember, so that was one of those things. So they're saying that if we have parallel lines and they are proportional, it cuts the sides proportionally. We find out that these are congruent, and we can use those. And then, of course, using congruent parts, we can go ahead and start utilizing that too. So let's see here. In this mid-segment, what do I know? It says if in the figure, EF and DE are mid-segments. All right, so that means that EF should be congruent to AD and DB, so these should be 9.2, 9.2. DE should be equal to AF and FC, and if the entire length is 15, that makes this 7.5 and this 7.5, therefore this is 7.5. So DE is going to be 1/2 of 15, which is 7.5. There you go. Let's see here. In the figure, so they've given us another figure, and they've told me that these are mid-segments. Midpoints creating mid-segments. So what do we know? Again, this should be congruent to this and this. So this is 19.5, this is 19.5. This should be congruent to this and this. So this is 16.25. This is 16.25. This should be congruent to that, making it 14, and congruent to that, making it 14. Now we just have to, we've labeled what we know, and we can turn around and say that AC is 2 times 16.25. We know that CB is 2 times 14, and you guys can figure this out. AH is, well, we got that 19.5. CG is 14, and AB is 2 times 19.5. So they're using our mid-segments. It allows us to fill in a lot of the information, okay? And then here, using proportional segments and transversals, pretty much the same thing, okay? So we just looking at this image, if I have 3 parallel lines and that means that these are split up as proportions. That means that I can set that equation up as x over 120 is equal to 96.5 over 102, and that would allow me to find that missing value. Okay, so when we multiply this out, we come up with our missing value. Just using it. I looked at the image and knew what they were asking based on what I'm presented with. If I come back and look, what are they asking me? It says that the developer is looking to purchase these two lots and to determine the length of the property's boundary that runs along the lake, the measurement known as the frontage, right? We want lake frontage. A measurement known as frontage. Find the lake frontage for lot 18, which is this unknown value, to the nearest tenth of a foot, so to the first decimal place. And that's what we could solve that. Here, using congruent segments of transversals, remember that if they said that if this is congruent to this, then this is congruent to that. So if we need to solve for x, we know that AB is equal to BC, AB is equal to BC. We make them equal to each other, and then we can solve for x. Combining like terms, I'm going to go ahead and move 2x over here. So I have 8 is equal to 5x minus 12. Add 12 to both sides. 20 is equal to 5x. Divide by 5, and x is equal to 4. So I was able to find x, and I know that these two sides are equal. So JK is equal to KL. Excuse me. Subtract y from both sides, and I have 3y minus 1 is equal to 8. Add 1 to both sides. 3y is equal to 9, divide by 3, and y is equal to 3. So I'm able to use those properties to solve, because I know because of those properties things are equal and congruent. And let's see here now. Using parts of similar triangles gets a little bit more convoluted, but it's all about being consistent with the way we set up our ratios. So parts of similar triangles. If two triangles are similar, then the lengths of the corresponding altitudes are proportional to the lengths of the corresponding sides. All right, so they're saying that here's my altitude, here's my altitude. If two triangles are similar, then they are proportional to the sides. So we could take a side, or the altitude, YW over SQ, would be equal to a side, YZ over ST. There you go. You could have used either side, but they were consistent. They used the smaller of the two sides. That's being consistent. And here it says if two triangles are similar, then the lengths of the corresponding bisectors are proportional to the length of the corresponding sides. Okay, so again, the bisector, EW over UQ, is proportional to DE over UT, or TU. You could have used EF. You could use EF over UV. It just determines which side of the legs you wanted to use. They should be the same. Okay. Let's see here. If two triangles are similar, then the lengths of the corresponding medians are proportional to the length of the corresponding sides. And again, the length of the median, right, that median is going to be RS over HJ is proportional to the side, and is proportional to the lengths of the corresponding sides. Well, they just happened to pick PQ over FG. Okay, so they could have been any of the proportional sides. And let's see here, angle bisectors, again, a triangle bisector. An angle bisector in a triangle separates the opposite side into two segments that are proportional to the lengths of the other two sides. Goodness, so BP, this segment over this segment, is equal to this over this. So again, this side of the opposite side over its side is equal to this over this. You know, it's really practice and being consistent. This is probably the most challenging, but there are ways to adapt it, and if you're solving with consistency, it's going to work out for you. Let's see here. So here, these similarities, and I'll just say that it looks like we have what would be a median, 18 over 27, right? So NP, the base, NP over YZ. So 2 times X, right? Because that's X, over 24 is equal to 18 over 27. And then we can go ahead and cross multiply. Cross multiply if you need to. Let's see here. So I would have 54x is equal to, I'm going to simplify these fractions first. It's just easier. These are both divisible by 2, so I have x over 12 is equal to, these are both divisible by 3, which is 6 over 9. Actually, they're both divisible by 9. Divisible by 9, that becomes 2 over 3. So therefore, we have 3x is equal to 24, dividing both sides by 3, and x is equal to 8. So there you go. The value of x is 8. That would give us the proportions that we're looking for. And let's see here, looking here, using a digital camera. Whew, goodness. A digital camera projects an image, through its lens and onto a sensor where it is converted into a digital image. The distance between the camera lens and the sensor is known as the focal length. Okay, the distance between the lens and the camera focal length. And is adjusted depending on the size of the object being photographed. The size of the object being photographed. And its distance from the camera lens. The distance from the camera lens. So Mrs. Elgin sets her camera up 3 meters from her subject, 3 meters away from the subject, who is 1.6 meters tall. Okay, and then if the sensor on the camera is 4.8 millimeters tall, and 4.8 millimeters is a conversion to meters. 1, 2, 3. So converting meters to millimeter, or millimeters to meters tall, and the optical focal point. So here we have what they're coming up with and trying to compare. Remember, being consistent. Looks like I have an altitude of this triangle and a base, and an altitude of this triangle and a base. So setting that up, if I have x over 0.0048, that would be equal to 3, again, my altitude of the other triangle, over 1.6. And that allows me to identify the information. So just using that similarity and being consistent with the shapes of my triangles and the sides I use. And then here, let's see, let's see here, traffic enforcement. The police officer is determining where to park his vehicle to observe traffic at a red light. If AC is 525 feet, so this entire length, 512 feet, RP is 384 feet, not drawn to scale, and Y is 201 feet away from B. And then how far is Z from Q? So we are looking for this value right here. So if I take the altitude of the small triangle over the base of the small triangle, it should be equal to or proportional to the altitude of the larger triangle over the base of the larger triangle. And then you cross multiply. 512 times x is equal to 201 times 384, and then we continue to solve for x, and that would find the distance that we were looking for. And then there we go, and we'll use the triangle angle bisector theorem. Gosh, let's see. This one was a little bit more difficult, but I will say that not difficult, just a little bit more vague. Again, using the information we have, this short leg over the side is equal to this piece over this side. Okay, and the challenge here is knowing that this little piece, they don't give it to us, but we know this is 12. We know the entire length is x, so this piece is actually x minus 12. So we don't know what x is yet, but we know we're going to subtract that bit of it, and that's how they came up with x minus 12. Then when you start doing your cross multiplying, we get 12 times 25 over 30 times x minus 12. Had to distribute this, so we have 300 is equal to 30x minus 36, or 360. Add 360 to both sides, and 30x is going to be equal to 660 divided by 30, and then x is going to be equal to, I want to say 22 should be the right number there. So coming up with that information. So let's see, so this one might be a little bit easier, I'm not sure, but again, the proportion, because we have angle bisectors, is going to be x over 16. So x over 16 is equal to this value, which is going to be 2x minus 1 minus x. So 2x minus 1 minus x is equal to x minus 1. So that is x minus 1 over 14. And now we can cross multiply. And you have 14x is equal to 16 times x minus 1. 14x is equal to 16x minus 16 because we had to distribute. I am going to subtract 16x from both sides just to get them together. And that becomes negative 2x is equal to negative 16. Divide by negative 2, the coefficient. And then x is going to be equal to 8. So that value is 8. There you go. That's using our triangles, our proportions, all of our similarity gets us into being able to solve problems by being consistent with our proportions.